Okay, ladies and gentlemen, welcome back to Math 1800, which is pre-calculus here at Wayne State University. My name is Rush Mahaber, and I just wanted to talk to you guys a bit about some shortcuts for graphing. This is section 2.5, 2.6, if I remember correctly, but I'm just going to touch base. That this is actually probably the coolest section in the world. And the shortcuts to graphing is really a topic called transformations. It really comes down to you knowing what graphs just look like in their most basic form. Okay, so for all medicinal purposes of graphing, I actually got a graph paper skin here. That should make things more accurate since my handwriting is already terrible. This should make things a little bit easier for us. So let me get my draw pad back. And let's rock and roll. Okay, so what do you mean by shortcuts for graphing? Well, I'm going to bring back a point of reference for you guys. Let's see how good you guys are. Do we remember what f of x equals x squared looks like? If you don't, we got to plot points. I'm hoping you do. All of you should say this is a quadratic. It's the squaring function. So it looks something like this. Right? See, that's why I got graph paper, because my handwriting is awful. So here we go. Let's plug some negative stuff in, some positive stuff. 0, 1, 2. You get 4, 1, 0, 1, 4. So I'm going to try to do this as accurate as possible if I could trace the lines. So at negative 2 is 4, 1, 2, 3, and 4. At negative 1, it's 1. At 0, it's 0, 1, 1, and now note, these doesn't mean it stops here. You better not do this. It's not a piecewise function. That's not what we want. We want to draw the actual graph. The actual graph looks something like this blob, and it touches right here at the vertex. Okay, if you remember the lambda. Okay, so every graph has some kind of focal point like this. In this case, a quadratic looks like a vertex, so they're all horseshoe shape. Now, this is not the only graph that has a particular look behind things. There are other graphs that are like this, like f of x equals x cubed. X cubed looks kind of the same way, except it's kind of S-shaped, and I don't know if you guys have ever seen this thing where it says, this is how mathematicians dance, and it gives all these pictures of s cubed and s squared and all this other good stuff, okay? So these are the two big ones, okay? Now your next question is probably, what does f of x equal x to the fourth look like? Well, it looks a lot like x squared, except for this. It's kind of like it grows really fast and does something like that. It goes up. So it's more u-like instead of more v-like. But we really don't bother too much with anything that's higher than degree 3, because at that point we have other tools at access. So I'm not going to worry about this one too much. Here's another good one. What about this? Have you guys seen this guy before? What does he look like? Alright, what does he look like? If you don't know, then what it does is it makes everything positive, right? Because it's the absolute value function. Well, that means that 0 should be at 0, 1 should be at 1, 2 should be at 2, 3 should be at 3, 4 should be at 4. So it looks like this, but if you plug in negative stuff, negative 1 gets here, 2, 3, 4, same kind of idea. It is a V-shaped, if you remember what this guy looks like. So this is also a guy that is also very common. How about this one? This is the only guy we really have that has a domain restriction. Oh yeah, domain. What do I mean by domain restriction? Can you plug negatives into this? No, it's an even root. So that means you can only plug positive stuff or 0, right? Because if you have a root, the domain restriction restricts you to strictly positive stuff or 0. So you plug in 0, it'll give you this. 1 to give you some crap here. 2, no, I'm not going to plug in 2, guys. Square root of 2, what do I don't know. I don't know what that is. How about 4? 4 gives me 2. 9 and give me 5. So you get some guy that's like really hooking. Looks like a curve. This is a really bad picture of it. Let me draw it better. Looks more like. Okay. And notice it goes up, but it goes up very slowly. Okay, very slowly. It might. And remember, at 25, you'll finally get to 5. So it's a very slow curve and never bottoms out. It's not asymptotic, meaning that it's not going to get close to a number if you are accustomed to that kind of a word. All right. So these are the 4 big ones you'll see. And yes, there are a whole bunch more, but these are the general shapes, like x cubed, f of x equals the cube root of x, right? The only basic way, these are the 4 important ones, but if you don't know what something looks like, here is the moral of the story. Plot points. If you can't figure it out, that's what we've always done for years, is plot points, figure it out, okay? But for guys who know what it looks like, we can actually move these around, okay? And I'm going to try to do this with the best of my abilities, knowing darn well drawing is not my best of my abilities, but I'll try. Alright, so here we go. So what do you mean by stuff happens to it? Well, let's start with a guy that's really, really basic. I'm going to start with this guy. Let's do x cubed. F of x equals x cubed. Now, once you have the basic graph, life is good inside because you can actually do what you want. But then there are 4 things you really have to worry about, okay? And if they appear here, then you're going to have to do some other work here, okay? I'm going to add 2 to the input before I cube it. Then I'm going to put a negative on the input before I cube it. And then after I cube it, because it's the cubing function, after I cube it, I want you to take the negative of it again. I'll put it in green. And then finally, let me not use gray. Gray is kind of weird. Let's put pink, purple, magenta is probably better. Plus 5 here. Okay. There's a process. There's a process to this, and I'm always going to go with the one that works the best, I think, for every course I teach. So once you get the basic function, so if you notice the stuff that's just in black, that's our basic x cubed function. So this is the first. I'm going to give you the process up front. First things first is identify which graph you're dealing with. Basic. So the basic graph. What is the basic graph? And the basic graph looks something like this guy. Okay. Now here are some keys here. There are 3 steps that I need you to take a look at, and then there's one more. Actually, maybe it's not 3 steps. First things first is you have to deal with something called the left-right shift. Okay? The left-right shift. Next thing you're going to have to do is deal with your flips. Now, there are 2 types of flips. There's what I would like to call a left-right flip, and then what I would like to call a up-down flip. Okay? And then finally, last but not least, I would like to call this guy my up-down shift. And people are like, well, you got to give me some time, guys. I'm building it up. And then the very last thing you do to really hone your graph in is find your x and y intercepts if they exist. All right. Here we go, here we go. So the basic graph, you're always going to start with the basic graph. So here's number 1. If you don't know what f of x, and what determines that is this cube here, x cubed looks like, you need to go ahead and draw it. So it looks like this. Okay? And everything up until the very, very last graph will just be a sketch. Okay? Just be a sketch. Okay, so now that we got that, let's take a look at this. See this plus 2? This plus 2 is actually counterintuitive, and this is the only one that's like this. This guy is the only weirdo, so beware, beware. Whatever it says, you're actually going to go the opposite direction on the graph. And I would encourage you to send me an email, otherwise I'll get into this long explanation that's going to run our video like for 45 minutes. So if you really want to know, send me an email and I'll be more than happy to explain it to you, or come see me in office hours, I'll be more than happy to explain it to you. But whatever's here, you're going to shift the graph counterintuitively in the other direction. So it's a plus 2. That means it's a left-right shift. That means I'm going to pick the graph up and move him 2 to the left. So this is going to be a left, we're going to left. Now, why I say counterintuitive? Plus 2, you would think it's going in the positive direction. No, it's going in the negative direction. It's going in the negative direction. So that means your graph is going to look something like this. So we're doing left-right shift next, and I'm going left 2 steps. So here we go. Boom, boom. Here is your basic graph. I'm going to dot the line for you so you can see it. Everybody see that? And then I want to move everything over 2. So this point that's at 0, 0 will not be at 0, 0. It'll be at 2, 0. Negative 2, 0. You see that? Just 2 steps over. And then here we go. So it looks something like this. Every point on that graph would do it, so the whole graph shifts. Everybody see that? So the movement is that it shifted left. And why is that? Once again, it's counterintuitive. That +2 is what controlled it. Now, for your viewing pleasure, if you notice, I've already color-coded them for you. So once we get here, check. We are going to use this red graph and do some stuff to it. What does this blue thing do, this negative do? Well, this negative does what's called a left-right flip. So what we're going to do is we're going to flip the graph, and I want you to picture this, picking up this entire graph, turning it over, and then shoving it back down. So people always say, well, what do you mean by turning it over? And what do you mean by flipping the graph? Okay, so I'm going to try to do this in the best way possible. Okay, so here's my third graph, right? And what controls this is this blue negative right here. Is this blue negative right there? If the blue negative is right there, then you won't have one of these. Right now I have, yes, I have one of these, so I must flip this guy left and right. So here's 3. And this is my left-right flip. Left-right flip. Here's my graph that's here. And it looks something like this. Now, if we're flipping left and right, this is where you have to keep things straight, because people don't keep things straight, right? I want you to view this line. It's kind of like a spinning point. Okay, so you're spinning the graph around this line. So if you can imagine, it's going to spin, this will spin this way, this will spin this way, and then all this stuff on this side will spin back over here, right? Okay, so you kind of can see the circular motion that's going to happen. It's going to swizzle around. Okay, so what does this mean? Well, let me get rid of some of this stuff. Okay, let me see if I can go back a little bit here. Alright, so let's get rid of some of this. Boom. Boom. Didn't work out too well, guys. I tried. Alright, so this will go, that goes, that goes, that goes, right? So I'm getting rid of all the lines because I don't want to draw too much on here. And then you can't see. Here I go again, erasing stuff I need. Okay, this is the best it's going to get. So we're going to spin across it. And I want you to look at this as looking into a mirror. If you look into a mirror, notice it doesn't just preserve your face. It's everything you see. So the whatever might be behind you, how far you're standing away from the mirror, the space in between, it preserves everything perfectly. So all of this will appear on this side. Right? This point, this little triangle will appear the same way. Right? This point will be the exact same as that point. You want to keep track of that too. It makes it easier. And then all this will be all this. Everybody see that? So it's spun around the y-axis. So we're flipping left and right. Your y-axis is your mirror. So it's a flip over the y because you're spinning this way. Is everybody okay? All right, moving on. And then that's part A, right? We'll call this part A. Part B, right, is a up-down flip. And I'm going to try not to jank up the picture like I did last time. Up-down flip. So I'm going to start my blue graph like I did last time, which is right here. And notice, I'm just sketching here. I'm not doing anything more special than sketching because I'll do my very last graph perfect. Okay, so that's where I'm at. Now I want to flip up and down. Well, same way like how I was flipping in this direction over here, I want to flip in this direction. So if I flip in the up-down direction, then what axis does that mean I'm turning over? I'm turning over the x-axis. So that means this stuff that's down here should turn up that way. And this stuff that's up here should turn down that way. Everybody see that? So the green line is where I'm at right now. So let me do something and dot some of these lines so you don't think I'm putting 16 graphs on one, because that's unacceptable. You can't put 16 graphs on one graph. That's no good. Okay, and I'll do the same thing to this guy because that looks real tacky when you... Okay, so here we go. So I'm left with the green line. So far, so good. All right, so now finally let me get my magenta pen out here. Boom. Now, finally, step 4. Step 4 says I have to do an up-down shift, but notice this guy is not like this guy. This guy said if I was plus 2, go left 2. If I was minus 2, go right 2, right? So it's counterintuitive. This is exactly what you think. That plus 5 means Finally, step 4, shift 5. Plus 5 means up 5 in the positive direction. Okay, this is an up-down shift, so you have to keep track of which shift is which. So I'm going to need my black pen. Let's do it. Alright, so I'm going to start with my basic graph, which occurs at 2, and it looks like this. Okay? Now finally, I need to shift this guy up 5. Let me see if I could do this without jacking stuff up. So this is 2 at 0, but 1, 2, 3, 4, 5. So this point is going to make its way up here, which means everything here should make its way up there. Likewise, everything here should make its way down there. Everybody see that? So right now, I have a really good sketch of this graph, a good sketch of what this graph is going to look like. But notice the last thing on our list is our x and y intercepts. Now, why is this the last thing on our list? Because this is just a freaking sketch, guys. Like, all I know is this point, but I don't know whether or not the graph does this, or whether it does something sharper. See what I'm saying? It's crossing at the x-axis in different places. If you find those, then what ends up happening is you get a more specific graph. So, here we go. Number 5. Find your x and y intercepts. Okay, so recall, what is your x, your y intercepts? Well, your y intercepts, which guy do you know? Well, the x is definitely 0. The y I do not know, ladies and gentlemen. So this is actually where it crosses the y-axis. So the y-intercept, you're plugging in 0 for x and you're solving for y. And likewise, the x-intercept is just vice versa. You're looking for the x and you're solving for the y. Okay, so the way I look at it, the question mark is what you're looking for. The other guy is 0. So now let's do some work here. Our function, I forgot what our function is. Our function is x plus 2 cubed plus 5. All right, so it's f of x negative 2 cubed plus 5. So for this function, you're plugging in 0 for x. Now, all this should be okay. If you're not cool with it, go back to section 2.1 where we talked about evaluating functions because you're going to need it. 2 cubed plus 5, which gives us negative 8 plus 5, which is negative 3. Moral of the story, our y-intercept happens at negative 3. Isn't that crazy? We got this thing up here in the sky. It's saying it happens all the way down here. All right. X-intercept, plug in 0 for your y, and let's solve for our x. So let me not make any boo-boos here, which I am good for. Copy errors are no good. Subtract it over, negative 5. Negatives go away when I multiply by negative on both sides. Alright guys, this is where you have to be cool with stuff. How do I undo something that is cubed? You better say it. Cube root both sides. Yes. Anybody know what the cube root of 5 is? Nope. That requires us to approximate it, which is okay, because it is a real number after all. Now finally, x equals, multiply by a negative on this side gives you this. Alright, does anybody know what this is? Because our point for sure is this. Comma 0. So what is this approximately? This is where you need to know some arithmetic. And if you guys always don't understand, like, arithmetic is the key. Alright, the cube root of 1 and the cube root of 8, that's 1 and 2. So the cube root of 5 should be in between there. So this is like 1.5-ish, okay? This means that this is like 0.5. The only reason I need to know where this is, so I know where it goes. So this is like right here, right there. Alright, so here we go. Let me draw my final graph now that I have both of these. Okay, remember I have this point, and I just kept track of it, is 2, 5. Okay, so here we go. Here's your final graph coming to a theater near you. Final. This point is at 2, 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This x-intercept is at negative 0.5 comma 0. So it's like right. Let me put it in a different color so you can really see it. 0.5 right there. And then finally, your y-intercept was at, where'd it go? is at 0, -3. So you can see it's barely a curve. It's barely something that looks like a degree 3. But here we go. Let's not screw it up. So it looks kind of like that. And like that. See that? It's not as curvy as I would like to call it. So here we go. Now label your points and label your axes, and you're ready to rock and roll. So this is 2, 5. This is 2 minus cube root of 5, comma 0. I know, don't freak out. It's okay. This guy is 0, -3. So it's not hard. It really isn't hard. You just have to use it. Now, these are longer problems. Why? Because there's 5 steps. You need to do a graph. You need to do a left-right shift. Flips, if they have them. Both of these had them. Now, you might not have both of these. You might only have one or the other, or neither. You know, and you might not have up-down shifts or left-right shifts. Okay, but this has everything. And then finally, your x-intercept, x and y-intercepts. All right. Let's say we do one more, and I'm going to speed through it as fast as I possibly can. Okay? Or as a matter of fact, let me leave you with it, and then you can deal with it. So this is what I want you to do. I want you to start with the square function. Okay? Next, and remember, the order matters. You have to do it in that order. It has to do left-right shifts, then flips if you have them, and remember, you have to keep track of which flip is which. Let me go back up here one more time. You have to keep track that the flip on the inside, that's your left-right flip, which means you're flipping left-right. And this guy is your up-down flip, which is your guy in green, which is out here. So let me show you what it would look like on another function. If it's this guy, this is what I want you to do. I want you to, first, I want you to shift. We already did one where you shifted that way. I want you to shift 3 to the right, the positive side, right? Then I want you to flip over the x-axis, then flip over the y-axis, and then finally I want you to go up 4. Okay? That's a good one. That's a good one. Notice how I just labeled everything in my head, so I can kind of tell you, and I'm going to speed through this, and I'll collect this in class tomorrow. I'm only doing this because we're running low on time here. I'm starting with the square root graph. I'm going to switch colors on you. 3 to the right. Boom. Flip over the x-axis. Flip over the x-axis. No, left-right flip, right? So I'll do one of these. So remember, see this space? It's not where we're flipping at the focal point, like I was getting ready to do. This space needs to be preserved. So if I flip over the y-axis, it should flip here. Okay, that's coming from this negative. And then finally, I need to flip down, which that's flipping over this axis, right? Up, down, right? So once again, this negative right here did a left-right flip, so flipping over this axis. And then finally, this one flipped it down. And then finally, I'm going up 4. So I should do 1, 2, 3, 4, right? So like right there. I'll put it in a different color. Say we did blue, red, green, orange. Does something like that. So you can already kind of tell we're not going to have a y-intercept, which we might not always have all the time. So I just drew all 4 graphs at once. So once again, you'll figure all this out once you do each graph individually. The expectation is that you graph each and every transitional step, so whoever's grading your paper knows where it's coming from, right? So you want to make a clear presentation. These problems are not shorter; they're a little bit longer because you have to do a bit more graphing. Okay, notice the sketching is just telling you where stuff is. Okay, so once again, if you have any questions, feel free to email me. Oh, what the heck! Another minute. Let's do this graph. I got overzealous. So this one is the one in class, right? That I'm gonna get from you in class. And actually, I'm gonna get this one from you in class too. This is what I want you to do. Get this guy. Okay. So what does this say? I need to start with the absolute value function. Looks like this. And I'm about to just muck this paper up really bad. Okay. I want you to go left 2. Then, notice I have no left-right shifts. I mean left-right flips, so I'm not going to flip any this way. I'm flipping all this way because of this. It has to come now, so it's going to do one of these. Green line, doom, doom, and then I'm going up 3. So if you look at the blue line, I'm going to have a y-intercept and x-intercepts. Easy, but you got to know the process and you got to know the order. All right, guys. So with all this being said, remember, in order to do somewhere you have do some things you've never done, you're gonna have to go some places you've ever been and start changing the way you guys think. So get uncomfortable, keep evolving, and I will get with you in the next video. Rush Mahaber signing off.